Hello everyone, welcome to my channel. Before we start this video, please subscribe, comment and share. In this video, I would like to explain about linear regressions. Linear regressions analysis using SPSS statistics. Linear regression is used when we want to predict the value of a variable based on the value of another variable. The variable we want to predict is called the dependent variables, or sometimes the outcome variables. The variable we are using to predict the other variable's value is called the independent variable, or sometimes we call the predictor variables. For example, you could use linear regression to understand whether exam performance can be predicted based on revision time, whether a cigarette consumption can be predicted by on smoking durations, and so forth. If you have two or more independent variables rather than just one, you need to use multiple regression. In this video, I will show you how to use a simple linear regression analysis using SPSS statistic. This guide shows you how to carry out linear regression using SPSS statistic, as well as interpret and report the result from this test. However, before we introduce you to these procedures, you need to understand the different assumptions that your data must meet in order for linear regression to give you a valid result. These are the assumptions before you do the linear regressions. When you choose to analyze your data using linear regression, part of process involves checking to make sure that the data you want to analyze can actually be analyzed using linear regression. You need to do this because it is only appropriate to use linear regression if your data possesses 6 assumptions that are required for linear regression to give you a valid result. In practice, checking for these 6 assumptions just add a little bit more time to your analysis, requiring you to click a few more buttons in SPSS statistics when performing your analysis, as requiring you to click a few more buttons in SPSS when performing your analysis, as well as think a little bit more about your data, but it's not a typical task. Before we introduce you to these 6 assumptions, do not surprise if when analyzing your own data using SPSS statistics, one or more of these assumptions is violated. This is not uncommon when working with real-world data rather than textbook example, which often only show you how to carry out linear regression when everything goes well. However, don't worry. Even when your data fails certain assumptions, there is often a solution to overcome this. First, let's take a look at these assumptions, at these 6 assumptions. First assumption, your 2 variables should be measured at the continuous levels. They are either interval or ratio variable. Example of continuous variables include revision time, measured in hours, intelligence, measured using IQ score, exam performance, measured from 0 to 100, weight measured in kilograms, and so forth. Second assumptions, there need to be linear relationship between the 2 variables. We list there are a number of ways to check whether a linear relationship exists between your 2 variables. We suggest creating a scatter plot using SPSS, where you can plot the dependent variables against your independent variable and then visually inspect the scatter plot, check for linearity. The third assumption, there should be no significant outliers. An outlier is an observed data point that has a dependent variable value that is very different to the value predicted by the regression equations. As such, an outlier will be a point on a scatter plot that is vertically far away from the regression line, indicating that it has a large residual. And then for the fourth assumptions, you should have independence of observations, which you can easily check using the Darwin-Watson statistic, which is simple test to run using SPSS statistic. We explain how to interpret the result of Darwin-Watson statistic in the next video. For the assumption, fifth assumptions, your data needs to show homoscedasticity, which is where the variance along the line of best fit remain similar as you move along the line. We explain more about what this means and how to access the homoscedasticity of your data in your enhanced linear regression guide. Take a look at the tree scatter plot, which provide the simple, and I will show you how to interpret the homoscedasticity in the next video. For the last assumptions, finally, you need to check that the residuals or error of the regression line are approximately normal distributed. Okay, we explain this next in the video. You can check assumption the second, the third, the fourth, the fifth, and the sixth assumption using SPSS statistic. For the second assumption should be checked first before moving on to assumption third, fourth, fifth, and sixth. We suggest testing the assumption in this order because the assumption number 3 until number 6 require you to run the linear regression procedure in SPSS statistic first. So it is easier to deal with this after checking assumption number 2 or the second assumptions. Just remember that if you do not run the statistical test of this assumption correctly, the result you get when running a linear regression might not be valid. This is why we dedicate a number of sections of our enhanced linear regression guide to help you get this right. And now we are going to set up in SPSS statistic by this example. For example, a salesperson for a large car brand want to determine whether there is a relationship between an individual's income and the price they pay for the car. As such, the individual income is the independent variable and the price they pay for a car is the dependent variable. The salesperson want to use this information to determine which car to offer potential customer in new areas where average income is known. I have data in my Excel. It's income and price. In SPSS statistic, we create two variables, and before we create two variables, we have to open your applications. IBM SPSS statistic. I use 26% of this. You can use this, or you can use the another version of SPSS. We open it, and we have to set up for the variables. We are going to create the variables of income as independent variables and the price as a dependent variable. Okay, we create the variables, and this we call income variables. Don't forget the measures of this is scale. And then this is the price. The second variable is the price, it's a scale. Okay. After this, check in data view, there is a variable income and price variable. We have to move the data from Excel to your SPSS view. We have to copy it and then we paste in this. It's so easy. This step show you how to analyze your data using linear regression in SPSS statistic when none of the 6 assumptions in the previous sections have been violated. At the end of this 4th step, we show you how to interpret the result from your linear regressions. First step, you have to click Analyze and then go to Regressions. Choose Linear on the top of menu and Show below. You will be presented with the Linear Regression dialog box. Transfer the independent variables, it's called income, into the independence box. Incomes transferred to independent box by click this button. Just click it and it can move. And then transfer the price into dependent variable by click this button. Now you need to check for the assumption discussed in the assumption before. No significant outlier, independence for observation, homoscedasticity, and normal distribution of errors. You can doing this the assumption by using this button statistic. You can check the menu here to analyze the assumptions. Dimensions, collinearity, diagnostic, and then just continue. After that, you have to check the plot. It is for homoscedasticity. You can put this onto X and then this onto Y. It's called dependent variable and X is independent variables. If you want to show the histogram, just check this and normal probability plot and then continue. This is for check the assumptions number 3, 4, 5 and 6, but here we just interpret the result for linear regressions. I will explain about the assumption in the next video. Click OK to show the result. Okay, SPSS statistic will generate with a few tables of output for linear regressions like this. In this section, we show you only the 3 main tables required to understand your result from linear regression procedures. Assuming that no assumptions have been violated. A complete explanation of the output you have to interpret when checking your data for the 6 assumptions required to carry out linear regression is provided in the next video that I will show you. So please subscribe this channel. This includes relevant scatter plots, histogram, normal, case-wise diagnostic, and the Darwin-Webster statistic. Now we are focused on the result for the linear regression analysis only. First table is model summary, and then NOVA. The last is coefficient. Okay, I will show you the 3 tables that we are focused. These tables, the first table is for model summary tables. This table provides the R and R square values. The R value represent the simple correlation and is 0.973. You can see in the R columns, which indicates a high degree of correlation. The R square indicates how much of the total variation in the dependent variable price can be explained by the independent variable income. In this case, 74.7% can be explained, which is very large. The next table is NOVA, which report how well the regression equation fits the data. This table indicates that the regression model predicts the dependent variable significantly well. You can see in this column. This indicates that statistically significance of the regression model that was run. Here's the value is 0.0, which is less than 0.05, and indicates that overall the regression model statistically significantly predict the outcome variable. It is a good fit for the data. The last table is the coefficient. The coefficient table provides us with the necessary information to predict price from income, as well as determine whether income contributes statistically significantly to the model by looking at the 6 columns. Furthermore, we can use the value in the B columns. In the B columns under the unstandardized coefficients. To present the regression equation as price equal, I will write in this, according to this table, we can make linear equation models. Price equal 9.29 plus 0.638 multiply income if you are this present as equation like this. If you are unsure with how to interpret regression, you can comment in the video below. That's all the explanation about simple linear regressions. Thanks for watching. Don't forget to subscribe and share this video.